what's your name here? You'll become a stranger.
Alright, here we go. Let's take a look at the next section. We're going to solve quadratics by graphing, and we're going to dive right into this and do some diving problems on this one. That was the world record holder for the biggest belly flop ever. Music by Skrillex. Love some Skrillex. That was kind of like Skrillex Light, though. That's from the movie Divergent. Get it? Divergent. Alright, maybe a stretch. So let's dive right in here and check this out. So we have done this already. We have solved quadratics. We did this with Mr. Sullivan. He did it by factoring. Remember factoring? If I unmultiplied this and I said, oh yeah, what multiplies to -3 and adds to 2? I did something like this. So jot this down with me. So if I factored this, it's really, really, really cool what's going to happen here. So factor that bad boy, I get this, and now I'm going to solve it. So it's nice that it factored. I get what? X equals -3. Whoa, X equals -3, or X equals +1, because it makes that 0. 0 times anything is 0. So why is that cool? Well, let's check it out. I want to graph this and see how do my solutions relate to the graph. So remember, graphing, I had to say, okay, what was A, B, and C. So remember, A was the number in front of the square, so that was going to be 1. B is 2, and C is -3. I plug that into my axis of symmetry. So you just pass this mastery check. So this should be good for you. So if I plug it in here, so I'm finding my axis of symmetry, I plug in negative B over 2A. What is A? A is just 1. So I've got -2 over -2. What is that? That's just -1. So my axis of symmetry in this case is -1. So I'm going to graph this just like last section. I could come over here and make a table of values if I wanted and plot some points, but do I have to do that? Well, I am going to need the vertex. So let's go ahead and find the vertex. Remember, I took the vertex and I said, okay, if x is -1, what is y? So let's put -1 in that equation and see what we get. If I plug in -1, I get -1 squared plus 2 times -1 minus 3. So -1 squared is just +1, yeah? And that'll be -2 minus 3 more. So I'm looking at what? Something like -4. And so that means my vertex when x is -1. So check it out. I've got this point right here. So that's old all review stuff. That is my vertex. I know it's positive. I know it's going to open up. That's my minimum. So I can make my table and plug and chug points. Do you really want to start plugging in chug in here? Sure, you could go if you wanted to, but check this out. These are the solutions right here. I already solved this equation. That's what makes this 0. Imagine if this was an equation. What if this was y equals x squared plus 2x minus 3? That means if x is -3, what's y? Oh, it's 0. -3 makes a 0 here, so y value would be 0. Also, if x was 1, y is 0. So check it out. That's where it's going to cross right here. So my solutions is where it crosses the x-axis. So now there's my parabola. I factored it. I've got enough points where I can just draw it in there. If you want to find the other points, you can, but I am done and done. So that is the whole thing right here. When I solve it, I'm looking for where does the graph cross the x-axis. That is awesome. Here we go. Let's jot down some definitions. We're talking roots. Roots are where a function equals 0. That's what we were just talking about. Things you may also see for roots. Sometimes they're called the x-intercepts. Where does it cross the x-axis? Sometimes they're called the zeros. Find the zeros of the function. It's like, where does it cross the x-axis? And what's the other one? Solutions. All these are kind of the same thing. Not exactly, but they're asking for the same thing. When does it cross the x-axis? So I threw a couple examples down here. Let's look at the first one. What are the roots of this function? I already graphed it. So boom, there's one right there at 1, and there's one there at 5. So the roots would be when x equals 1 or 5. Fantastic. What's the vertex? Remember, that's from the last one. It looks like it's over 3 down 4. Fantastic. Does it freak you out if I say x-intercepts? I hope not. There they are. It's the same thing. It's when x equals -3 or 1. The difference on x-intercepts, we usually would say, oh yeah, x-intercepts are a point. They're actually referring to the point, where roots are just saying what is the x value that causes that to happen. That's a minor difference. If you stick with just x equals, they'll be okay for this section. And then the max or min, same thing as a vertex. The max in this case is -1, 2. And then the last one I just want to make sure we got terminology is zeros. If I ask you for the zeros, oh, check this out. This is weird. Notice I put in parentheses. That's a big hint. It only has one zero. In this case, x equals -4 is the zero. So it can have one solution, two solutions, no solutions even. And that zero is actually the vertex, -4, 0. So that is our vertex there. So if I give you the graph, pretty easy peasy. Just write them down. Now let's get into the calculator. Diving into the quadratics. This is a meme I made. Are they memes? 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 I don't know. A meme that I made. Diving into quadratics. It's a little bit painful for some people to do the calculator. Don't be that painful. Calculators are great. You can use them in all your college prep tests, things like that, SAT, ACT. So don't freak out and make these painful Wait, is that Sullivan? And Kelly, that is a creepy face, Mr. Kelly, Mr. Brust, down there. Unbelievable. Let's get rid of that thing. That's rough. And let's solve these by graphing. Now, I'm not going to graph all these. When we're solving them, we're going to get some crazy answers. So what we're going to do is, you got to set equal to 0, and we're going to say it's just y equals 2x minus 3x minus 7. We're going to put that bad boy on our calculator, and I think you'll see why here in a second. So to put them in, we got 2. Remember, here's the x button up here. 2x squared minus 3x minus 7. And we're going to zoom standard. That zoom 6 gives us that nice basic window right there. And there is a great graph of it right there. So if I just had that graph, boom, there it is. That's awesome. If I want to find the solutions, well, there they are. I can see them right there. The problem is they're not friendly. Those nice numbers you got, yeah, that means you could factor it. But factoring doesn't happen really in real life. That's just kind of like fake life, where they work out friendly for you. Real life problems usually don't factor. So what are we going to do? We're going to use this feature right here in blue above right above trace. It says calc. So we got to hit, because it's in blue, we got to hit second trace, the calc. Which one of these are we looking for? We're looking for the zeros. So remember, roots and zeros are the same. So number 2 is 0. Well, you have 2 of them, so the calculator can't tell you unless you define it. So let's go to the left root. So I know it's over here. I put the little cursor, little thing right on the root, as close as I can get. So it looks like that's a pretty good approximation. But we want it exact. So it's saying, what is the left boundary? So that means you need to get left of this root. So you need to hit left like 2 or 3 times. So I'm definitely left of it. Hit enter. Then go back to where that root was. And now it says the right boundary. So you got to go right 2 or 3 times. Hit enter. And if you notice, it's making these little arrows up here. That means it's looking in here for roots, because you could have several roots. So it's only looking here. You don't have to guess. You just hit enter again, and that is my exact root. So I'm going to bring that one over here, because that has my actual answer on it. So I'm going to trump that one. Hey, and that is the exact answer. So I'm going to have you round these things to the nearest hundred. So we're going to say one root is at -1.27. See, I rounded that bad boy up. Where's the other root? So I know it's over here. Well, I got to go back to my calculator, and I got to do it all over again. So I'm finding the 0. This time you have to bring your cursor over to this root. And again, we're going to do left boundary, right boundary. So left, just hit left 3 or 4 times. What tricks people out, it's not above or below the graph. It's always left or right. So I'm definitely left of it. Go back to the root, hit right a couple times, boom, hit enter, guess, hit enter again, and there is my other root. So that is 2.77. So 2.77. So these are the solutions. I just solved that, so there was no factoring going on. This, in fact, doesn't factor. This is crazy decimal. This is the solution as the approximate decimal. Pretty awesome right there. Pretty cool. How about the next one? Let's do the next one together. Can't do this until I solve it for 0. So remember, you got to set them equal to 0 first. So just like we did before, we're really looking at -1/2 x squared plus 5x plus 8 equals 0. And now that's my y equals. So really I'm saying, yeah, that's what y equals. So I'm going to type this into the equation, and let's clear this one out. What do you do with 1/2? Well, you can put 0.5. Another good practice for fractions is just type it in and put in parentheses. I think you're okay without, but that'll keep you safe right there for sure. If you put in parentheses, plus the 5x plus the 8, and then we're going to just graph it or zoom standard. And it looks something like this. Whoa, wait a minute. So I can see it's a parabola. Remember, I know it's opening down because of that negative there. So it's opening down, so it's going up off the screen, then back down. So I can find this root no problem. Like, we can come over here and do our little thing. I see this root. I'm close to it, so I hit the left boundary, hit left of it a couple go back to it, get rid of it a little bit, and I can see that one, no problem, negative 1.4. That's not the issue. The issue is going to be that other one's off the screen. So this is the hardest part of the calculator. This is why people don't like the calculator sometimes so much, is the window. Remember, I'm showing a 10 by 10 window. So if I look at this graph, it is going to 10 out here, 10 up here, negative 10, and negative 10 down here. So what do I need more of? Well, this is the x-axis, this is the y-axis. So yeah, if I want to see the vertex, it's coming up here, something like this. But I'm more concerned about it hitting, where does it hit out here? So what do I need? I need more x, and this is in the max direction. This is the positive. I mean, that's max is the maximum positive, min is this direction. So for the y, it's the opposite. Down here's the min, and up here is the max. So if I go back to my picture, I need to go to my window and say, hey, I need more x max. I'm only going to 10. Maybe I need to go to 15. And then this is just what you want to count by, maybe ones or twos or whatever. So I'm pretty cool with ones. Stretch that out to 15. Was that enough? Yes. Now I am out there at 15 somewhere. So I'm going to jump my cursor out there and say, okay, I want to find this point. So what am I going to do? I'm going to hit calc, 0, boom, get left of it, boom, get right of it, hit enter again. And now I've got a really nice window, 11.14. So I'm going to bring in my nice window here for that. Whoa, what is that? Let's try that again. And so my other answer, just so we have it, was 11.4. Excellent. So these are my two answers right here. Awesome. That looks pretty rough there. Go ahead and try the next one. I'll help you solve it for y if you want, but and it doesn't matter which side you bring it to. It may change if your parabola opens up or down, but you're going to get the same answer. So just to make it easier, I think I'm going to go from this side to say my 0 equals negative 2x squared plus x minus 5. Go ahead and type that bad boy in, see what you get, and give me those roots. Alright, I got it typed in here, and I messed with the window, so I'm going to go back and zoom standard. I always like to reset myself at zoom standard so I know where I am, and graph that bad boy. Oh my goodness, did you get that? Yes, I was messing with you. This is what happens here. Where does this cross the x-axis? It doesn't. This is no solution. Not going to happen. It never crosses. It has no roots, has no zeros, has no solution. You cannot solve this. Boom. I was just messing with you there. No solution. Awesome. Moving on then, let's go ahead and find max and mins. And all that means, remember last time, is finding the vertex. So I have this, let's take the first one, and I'm going to clear out that old mess right there and type in the new one. So I want to find the maximum and minimum of this, and this is really good for word problems. This comes up quite a bit. I'm going to get my zoom standard on, and there it is. So I can see there's the minimum right there. So I have the minimum. How am I going to find it? Well, let's go back to our second trace here, or calculate. Do you see a minimum? Yeah, number 3, minimum, right there. It works the same way as our zeros. You put your cursor right on where you think the minimum is. That's a pretty good estimate. Then get left of it 3 or 4 times. Hit enter. Go back to where you think that minimum is. Boom, it wants the right boundary. Go right 3 or 4 times. Hit enter. It's only looking between these two arrows because you can have more than one minimum. Later on, we'll get some crazy functions. You got to hit the guess button, and then there it is right there. This is interesting here. The calculator's, a little bit off when you've got this many zeros. It's okay to round it to. This is definitely negative 0.75. And we're not doing x and y though. What are we doing? We're doing it as a point because it is the vertex. So it's this and negative 6.125. Excellent. So I'm going to look for these. I'm going to make sure these decimals are right. You can't just trace and guess. And then my sketch, I have a very good sketch, is right there. Excellent. Okay, wait, let's try this one together. So again, I got this fraction thing. I'm going to bring this one over here. It doesn't really matter which way you go here. So I've got this going on. Those cancel out, and I've got that. So really, I'm going to set my y equals to that. So I'm going to throw that bad boy in there. Notice I use 0.75 instead of 3/4, but you can type it in there. And we're going to zoom standard again. We got this window. Uh-oh, what happened here? Remember, check it out. Oops, I want that screen back. I want this thing. So I have this, and again, what's happening? It's coming up and then coming back down, so I need it. My maximum point is way up here, so I got to mess with it. So I got to change the window. So again, once you get the window down, you're styling. So how do I change the window? Well, what direction is this? This is the y direction, up or down. I need more ups. I say it all the time in basketball. I need more ups. So I go to my window. What is more ups? Remember, that's the y maximum in the positive direction of the y. I need more. Maybe we need to go to 20 And I'm going to change my scale. If I'm going to 20, maybe I'll count by fives, just so I can see a little more. Ooh, that turned out pretty well. So I can see my roots or my zeros down here, and then this is the actual vertex. So go ahead and practice getting this vertex, and not only that, go ahead and do the next one. So I want you to finish this one and get the next one. Pause it, see how that goes. All right, here we go. So I went ahead and solved this one. I got negative 4.6 repeating and 18.3 repeating. This one I thought we'd do together. So were you able to figure this out? So remember, it comes down here and then up. So I'm looking for this minimum here. Were you able to change your window? What is the window going on? This should be our y direction going down in our minimum direction. So maybe you got to change this to negative 15. Is that, oh, I should probably go a little bit more. So maybe I'll try negative 20 again, or just like the other one. So put that in, and I'll count by fives, and now I have it. And let's finish this out. So I'm going to find my minimum. Boom, get over there. And once you do a couple of these, it gets pretty fast. You get left of it, you've got to get right of it, and then you have it right there. Excellent. So let's put the real nice friendly graph over there, and I like to write this out. It is a point. The minimum point of this is negative 6.25, comma negative 15.44. So we're rounding to the hundredths there. Excellent. That is the vertex. Can we put this together? So it doesn't make much sense without a word problem. Like, I'm going to keep them around that normal 10 by 10 standard window. But when we're talking word problems, now I'm going to give you some crazy windows. And I'm always going to say, what's the friendly window? What makes sense for this problem? So let's look at cliff diver Kelly. He loves to go cliff diving. 70-foot cliff. So here's a cliff. And here's some water down here. And here's Mr. Kelly. He's going to dive into the water here. So we want to represent this. This is that vertical motion of Mr. Kelly's height over time. So S is his height as it changes over time. This is gravity, negative 16t squared. That's the gravity pushing him down. V is his initial, it's his ups. This is his initial jump up. And H is his initial height. Where does he start from? So let's plug in the things for our equation. So his height over time, this doesn't change. It's negative 16t squared. That's gravity. What did he jump with? He jumped 8 feet per second, so that's my V. And how high is this cliff? We've got a 70-foot cliff here, so that's going to be plus 70. So there's my equation right there. Now I want to graph this with a friendly window. So now it can get a bit trickier here. Let's type this bad boy in. You can't use t. It's always x, so that's just our variable. So just know x stands for time in this case. And if I zoom standard, probably not much going on here, I'm guessing. Yeah, that's not friendly. Like, yes, there's a parabola there. It's shooting way up, shooting way down. But I got to change the window. So what does x stand for? Well, x is really t. Remember, t in this case is time, and it's being measured in seconds. So that's the important part of these word problems, is putting it all together. What does it mean? In this case, y is the s, which is what? It's the height of the diver. It's the height of Kelly, and that's being measured in feet. So that really helps with the windows, because I go here and say, okay, what's my minimum time? Well, 0 is in word problems, 0 is a great place to start. If you don't know, try 0. That's like right now. I'm going to start my timer now. Right as he jumps, I start it. How long is he in the air? I don't know. 5 seconds, 10 seconds. I'm going to stick with 10. That sounds pretty good. And counting by ones. And then my y minimum is what? That's the height of Mr. Kelly. I like this negative 10 because he actually will go underwater. If you put 0, that's cool too. And then what's the max? Well, the max has got to be at least 70 because that's how high the cliff is. I like to show a little extra room, so I like to go to 80. Maybe I'll count by tens, and let's see if we get a pretty good graph. Awesome. So this is a good graph. I have a way too much x here, though. Like, you're not in the air that long, so maybe he's only in there 5 seconds. Let's tone that down, make this a little prettier. So you can see he jumps up, comes down. This is a nice, friendly graph. Looks just like this one over here. Can you find real quick, use that picture to find when Mr. Kelly hits the water, and what is his maximum height? Good luck on that. All right, here we go. So when will Mr. Kelly hit the water? Well, you've got it right here. You can see it's the root, it's the solution. So what does this mean? That means 2.36 seconds. That's how long he's in the air. That's when he'll hit the water. What is Mr. Kelly's maximum height? I got to go down here. So that's the vertex. The maximum height is what? This means what? This means at 0.25, so at a quarter of a second, he is this many feet. So he only got up to 71 feet. Nice jump, Mr. Kelly. We'll play it from 70 to 71. Dude's got some ups on him. He jumped a foot. There it is. There's the application. We're going to end you with how do you go cliff diving if you don't have any water? These guys found a way to do cliff diving without water. Good luck on the match check. Peace out.
Forget your name here, you'll become a stranger. You'll become a stranger. Forget your name here, you'll become a stranger.